Operators are driven to start deploying network slicing solutions now to tap into the business-to-business opportunities created by 5G. A key success factor is the ability to quickly answer customer needs in an economical way. However, the complexity of managing a large number of slices and customers threatens the whole 5G business model. Automating the entire lifecycle management of a core network slice enables you to overcome that challenge. This demo video shows how the Nokia Network Services Platform, NSP, orchestrates the allocation and configuration of two core network slices. The first core network slice implements an enhanced mobile broadband use case as defined by 3GPP and requires the deployment of three network functions: one access and mobility management function, or AMF, one session management function, or SMF, and one user plane function, or UPF. The second core network slice fills the demand for an ultra-reliable, low-latency communication use case. This slice reuses two functions deployed for the creation of the first core network slice as shared components, and it requires the deployment of a dedicated user plane function. To create these core network slices, the NSP acts as a network slice subnet management function for the orchestrated deployment of the core network functions and the data center networks that connect those functions, and for triggering the core slice configuration, and as a network function management function for the configuration and monitoring of the core network functions. Those NSP components are fully compliant with 3GPP Release 16. This demo also uses Nokia Cloud-Band Network Director as the Cloud Operations Manager for the instantiation of the core network functions, and OpenStack Neutron as the Data Center SDN controller to establish data center networks. To automate the allocation of the core network slices, NSP uses deployment templates. There are three types of templates: the network slice subnet template, which describes what core network slice to create and what network functions are needed; the network service descriptor, which describes what network functions to instantiate, connect, update, and terminate; the network configuration descriptor, which describes what network functions to configure. The templates are created once by the domain experts and can be reused many times by the network operators. The templates describe the attributes and requirements that are necessary to realize network slices, network functions, or data center networks, as shown in this example of network service descriptor. The NSP selects the proper templates depending on the intent of the operator. This intent is expressed by the operator using the NSP Network Orchestration app. Alternatively, the intent can be passed to the NSP through its API. Let's create our first slice. A set of 3GPP compliant attributes that configure the network slice need to be defined. The slice profile ID is the name of our first slice. The NSSI list includes two attributes. The slice subnet type defines the kind of slice: enhanced mobile broadband, ultra-reliable low-latency communication, or massive machine-type communications. EMBB is selected for our first slice. Second attribute, the service differentiator, is a string that differentiates slices from the same type. Clicking the Allocate button triggers all the steps needed to deploy the slice. This is the only action required by the operator to create the slice. All the rest is automatic. Let's click the Allocate button to send the request. The NSP network orchestration intercepts this request to identify what network slice subnet template to use. From this template, the NSP knows what network service descriptors to trigger and it auto-generates inputs to them. The Cloud Operations Manager parses the network service descriptors to deploy the network functions and to connect them. The first network service descriptor is being executed to configure the data center tenants in the OpenStack. The tenant identifies the owner of the core network slice. Then the second network service descriptor is executed to deploy the data center networks that are needed to establish connectivity between the network functions. In the OpenStack Neutron, we see all the data center networks that have been automatically created and that are being configured based on the content of the network service descriptor. Once the data center networks have been deployed, the Cloud Operations Manager executes the network service descriptors to successfully deploy the AMF, the SMF, and the UPF. Looking under the hood, when the Cloud Operations Manager executes a network service descriptor, such as the AMF, it generates a collection of workflows. Each workflow executes tens of REST API calls towards the resources. From our core network slice, these workflows represent several thousand lines of code that are generated automatically when the network service descriptors are executed. Once the network functions are up and running, NSP discovers them. The network slice subnet template once again indicates to NSP what network configuration descriptors to use to automatically configure the network functions. In the NSP Intent Manager app, we see 3 managed elements that have been configured. Then the NSP dashboard shows the success or failure of our core network slice deployment. We can see that the deployment of the core network slice is complete and the slice is healthy. A graphical representation shows all the slice components: tenant, data center networks, AMF, SMF, and UPF, as well as an overview of the attributes of the core network slice, as defined in the initial request. The network functions are visible in the NSP Network Supervision application. The SMF and UPF are grouped under the Cloud Mobile Gateway, and the AMF is visible in the Cloud Mobility Manager. Now let's create our second slice. The operator fills out the attributes of the core network slice in the NSP Network Orchestration dashboard. Attributes are the same as those for the previous slice, except the slice subnet type, which is now ultra-reliable low-latency communication, and latency is much more stringent. The core network slice can then be allocated. In the Cloud Operations Manager, a new network service descriptor is being executed to add additional networking parameters to the existing networks. A new dedicated UPF is now being deployed. Once the UPF is deployed, the NSP discovers the new network function and pushes the configuration to it. On the dashboard, we can see that 2 slices are created. The second core network slice, consisting of 2 new components, data center network and UPF, is deployed and configured. This new core network slice is reusing the previously deployed AMF and SMF. In the NSP Network Supervision app, we can see that the Cloud Mobile Gateway now includes an additional network function, which is the UPF that we just deployed as part of the second slice. In the NSP Intent Manager app, we see 4 managed elements: the AMF, SMF, and UPF from the first slice, and the UPF from the second slice. In this video, we have shown how the NSP can quickly and easily deploy 2 core slices made of shared and dedicated network functions. Each core network slice is created through the click of a button. The NSP uses the deployment template to automatically instantiate and configure the network functions that constitute the slice, and connect these network functions in the data center. This level of automation effectively streamlines operations to meet expectations for service velocity, to reduce errors, and to improve service quality.